ఇట్లా నాకు నీకు తెలుసు, నాకు తెలుసు, నీకు తెలుసు అని నాకు కూడా తెలుసు, నీకని కాదు అందరికీ తెలుసు. ఇక్కడ ఆల్రెడీ కొంచెం హింట్ వచ్చింది అక్కడ. ఆ హింట్ని యూజ్ చేసి చెప్పు. తను యూజ్ చేసిన టర్మినాలజీ యూజ్ చేసి చెప్పు. తను సమ్ టర్మ్స్ యూజ్ చేసిందా? బై యూజ్ రైట్, చెప్పు. It is incomplete statement, I'll say. Make it complete. ఇంకొక వే ఫ్రేమ్ ఇస్తా. ఇది ఫస్ట్ ఫిగర్, సెకండ్ ఫిగర్, ఇది థర్డ్ ఫిగర్. ఓకే. Now tell me, when construction, when destruction? Construction, destruction because of interference. Interference means interfere. Interfere means one wave, more than one wave, more than one wave. So two waves minimum. So which two waves I have to take for construction, which two waves I have to take for destruction? డయాగ్రామ్ చూస్తున్న కొద్దిగా ఐడియా వచ్చిందా? రైట్, మీకు ఈ డయాగ్రామ్ చెప్తే అర్థమైంది. సరే, ఇక్కడే వాడేస్తలే. Is it visible, this color? Left side, outside, back sides. Which color? Okay, this I will take. Now? Tell me now. I think this diagram same, not same. చూసినట్టు అనిపిస్తుందా లేదా? ఇప్పుడు చెప్పండి మరి. ఓకే, లెట్ us say this is A and this is B. సో డయాగ్రామ్ వచ్చింది కనుక ఆన్సర్ వచ్చేసింది. ఏ డయాగ్రామ్ ఫర్ కన్స్ట్రక్టివ్ ఇంటర్ఫిరెన్స్, బి ఫర్ ఓకే. నౌ ఎక్స్ప్రెస్ ఇన్ వర్డ్స్. ఓకే, వాట్ యు సెడ్, see the diagram, express in words. Either you or anyone in the class take this chance to speak. డయాగ్రామ్ చూస్తున్నా ఐడియా వచ్చిందారా లేదా? కాన్సెప్ట్ వచ్చిందారా లేదా? టెల్ మీ నౌ. దీస్ ఆర్ ఫండమెంటల్ బేసిక్స్. అమ్మా, నౌ యూ కెన్ యూజ్ యువర్ టర్మినాలజీ అండ్ ఆన్సర్. కూర్చో సాయి. What's your name, Amma? Archana. Now use your terminology and tell. What term you used? By using them, you explain. Say in English. Speak in English. No problem with the language, with the grammar part. Speak. No problem. Try చేస్తేనే వస్తుంది. టీవీ చూస్తావా? ఇంట్లో టీవీ ఉందా? ఈ మధ్య కొత్త ఒక అడ్వర్టైజ్మెంట్ వస్తుంది, చూసారా? రీసెంట్గా ఒక 1-2 months నుంచి ఒక అడ్వర్టైజ్మెంట్ వస్తుంది. 3 housewives, దే డిస్కస్. మై హస్బెండ్ స్కూటర్ లైక్ దట్ షీ విల్ సే, బికాస్ షీ వాంట్ టు ఎక్స్ప్రెస్. లైక్ దట్ యూ స్పీక్. అబ్బో, డైరీ మిల్క్ అంటే తెలుస్తుందా? అక్కడ అన్నోను మీకు డైరీ మిల్క్ కల్పించిందా? మీ అబ్జర్వేషన్ డైరీ మిల్క్, నా అబ్జర్వేషన్ షీఈస్ ట్రయింగ్ టు ఎక్స్ప్లెయిన్ ఇన్ ఇంగ్లీష్ లాంగ్వేజ్. చూసారా వే ఆఫ్ అబ్జర్వేషన్ మీది నాది. మీరు తినేది చూస్తున్నారు, నేను అరే ఏం చెప్పాలని ఆలోచిస్తాను, నేను ఆలోచిస్తున్నాను. తప్పలేదులే. ఇప్పుడు ఏం చేస్తాను? తింటావా చెప్తావా? రైట్, చెప్పు. గుడ్. తెలియదు అనేది లేదు. మినిమం ఇంగ్లీష్ వస్తుందా? ఎస్, కమ్ము, గో, కమ్ము, సిట్, స్టాండ్, అట్లాంటి టర్మ్స్ యూజ్ చేసి చెప్పు. ఎస్. ఓకే, గుడ్. ద ట్రయింగ్ ఐ వాంట్. నైస్. So who will re-spoke or who will re-express the terms? Okay na, China? Shall I? సెకండ్ యూనిట్కి వస్తా, అది లేదన్నాక ఆగేసాను. ఓకేనా, స్ట్రీమ్ అవుతుందా? నేనేమన్నా 10 minutes ఆగుంటే 10 minutes ఇది డిస్కస్ చేస్తున్నాను. Yes, sure, sure. All are busy. What you said, please stand and speak అంటే నోట్లకెళ్ళి మాటలు రావు. నాట్ ఓన్లీ యూ, ఆల్ స్టూడెంట్స్ అంతే. సైకలాజికల్ ప్రాబ్లమ్ అది. ఫియర్ ఎందుకు అవసరం? ఆ ఫియర్ దీని ఏమనాలి? ఏమంటాం? మీన్స్ the maximum displacement of the vibrating particle from its mean position. Actually, how a wave is going to form? Because of vibrations of the particles. Maximum displacement from its mean point. This is called mean point, and these are called extreme points. Either you take upside or you take downside. This is called as amplitude. Then what about this? Start in the okay. This is what? Wavelength. What is wavelength? Distance between 2 points which are in phase. Distance between 2 points which are in phase. Phase means position as well as direction. So this is, what is the difference between these two? This is missing or not? Okay, this is 0.0, this is pi. So difference between this is pi minus 0 is how much? Phase difference is pi radians. In phase, out phase. Out phase. Out phase means if these two waves are going to interfere, destructive interference. If these two waves are going to interfere, constructive interference. Constructive interference resultant amplitude is going to, if these two are going to interfere like this. Okay, so what is the resultant amplitude? Like this we used to take resultant R. So what happened to resultant amplitude? Increased. If I take which type of interference? Destructive interference. This is constructive and this is destructive interference. What will be the resultant amplitude in this case? Small one. If I take this amplitude is A1, this amplitude is A2, then A2 difference A1. In this case this is A1 and this is A2, and what about this? A1 plus A2. Constructive interference, destructive interference. So this type of pattern gives you bright band This will give you dark blue. Here both the particles are starting from same point in phase. There is a phase difference of pi. Out phase, in phase, out phase, constructive, destructive. Okay, right. No adding. Abba. Crystallography. The title that I want to speak is about crystallography. So what is crystallography? What we are going to see in this unit. Here in the title itself some information we get regarding what we are going to study in this. In this topic, what we are going to see, that information we are getting from the title itself. So when you break the title into parts and see, you will get some information. So can you break and say what it is? Crystallography. We can break it or not? Crystallography. So crystal, what is there or not? This crystal means we are going to discuss about crystals. Inside crystal, how the atomic arrangement are there. Why we have to study? Because we used to come across many metals. Their electrical property, thermal property will be same. Different metals has got different electrical and thermal properties. Why they are showing different? If all those things, if you want to know, then its basic structure you have to see it. Okay. So for that purpose, to know about that basic structure, some methods, some experiments we are going to do. With that experiments, some results we are going to get. We are going to analyze them, then we will come to some conclusion. Yes sir? No? Without doing experiment, can we conclude? No. Some experiments will be done. XRD experiment, Louis one method, powder one method, like the different methods are used to study about the crystals. From those methods, some results we get it. We analyze those results and we come to some conclusion that the crystal is so and so. So before knowing about all those things, some fundamentals related to the crystallography we have to know, the technical terms that we are using in this. Okay. So before knowing about that, one example I want to take. Let us take, this is one classroom. Okay. So some name will be given to this classroom, am I right? So what is the name given to this classroom right now? It is? Right. Yesterday also some class took place in this. What was the name given to this classroom yesterday? Same, huh? Yesterday also you sat here only? Morning, afternoon? I am saying about morning. Okay, right. My question is incomplete then. Yesterday morning some students sat here. You only? Some other students sat. So what is the name given to them? To which class they belongs? Some other than your branch name, we can say it or not. Same name is given for them also? Let us say it is CSC Ankunda. You are CS, they are CSC. Why they are different? Why different names are given? What is changing? Branch is changing. How the branch is going to change? Who is changing? Students are changing. Who? Hello? 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 Okay. Is it audible? No. Hello? Hello? Okay. Is it audible now? Right. So a name is given based upon the student who is occupying the place. If student is changing, okay, right. So which branch student is sitting in the class, that particular name will be given to that class name. Am I right or not? But hello, right. What is fixed in this classroom? Hello. What happened? Okay, I'll give you a chance. Please stand and speak. What is going on there? Last but one. Busy in chatting, huh? Then why are you turning? Right. So only student is changing. Any other changes we can see beyond this? No. Right. So student is changing, particular name is given. This clarity is there. Right. Once when student come inside, what he will do? He will stand up. He will be sitting. Where he will be sitting? Places are allotted. Based upon the place he will sit. Yes or no? Right. So finally, in the places student is sitting, then a name is given to the classroom. Like CSCA, CSB, something, something, something. Yes or no? In the same way, a crystal is made up of, it is a part of a solid, it is made up of atoms. Crystal is made up of atoms. Where we find atoms? In some places we can find it or not. Like I find a student in the classroom where? On the chair or on the desk. In the same way, I can find atom inside the crystal. What we have to say? It is called a lattice point. What we say? Lattice point means points. What is a lattice point? Only classroom, only one chair will be there. Many chairs will be there depending upon the strength. In the same way, lattice points are imaginary points, extended three-dimensionally, where we can find a atom, molecule, ion, etc. inside the crystal. Okay, now that is lattice point. Right. Which atom? Before that, actually before this about crystal, we must know the difference between types of crystals actually. Crystals classified into two types: crystalline solids amorphous solids. So, what are crystalline solids and what are amorphous solids? Some difference might be there or not. So, what are the differences? Crystalline one. Crystalline solids, amorphous solids. Some differences will be there between them. Let us take some important differences. Okay, right. Crystalline solids, amorphous solids in terms of atomic arrangement. First difference in terms of arrangement of atoms. How the arrangement of atoms will be in crystalline as well as amorphous. The regular arrangement of atoms we can see. if the arrangements of atoms are regular in crystalline, then what we can say about amorphous? Opposite of regular. So arrangement is irregular. What are irregular? Which are irregular here? Atomic arrangements. Regular arrangement we can see in crystalline solids. Irregular arrangement we can see in. Now let us take this classroom is an example for a crystal. If I take, the students are the atoms. How they are sat? Some regular fashion or irregular fashion? Regular fashion. If the same classroom, if I take in the ground, think you are in ground, how the student arrangement? Rows and columns I can see in the ground. Here I can see rows, 2 columns, multiple rows. But can I find that rows and columns in the ground? Right, if student here regular, student there irregular. In crystal also atomic arrangement equally spaced regular, random spaced irregular. Next, because of regularity in arrangement inside the crystal, what we can see? Symmetry. What we are going to say? Symmetrical. You know what is the meaning of symmetrical? This exactly I can say is possess internal spatial symmetry. Okay. Non-symmetrical. What is the meaning of symmetrical? You know symmetry. What is symmetry? What is symmetry? Some knowledge is there regarding this. విన్నారా ఎప్పుడన్నా సిమెట్రీ వర్డ్? ఎక్కడ విన్నారు? ఎక్కడ? మ్యాట్రిసెస్. ఎగ్జాంపుల్ ఇవ్వండి. సేమ్ మ్యాట్రిక్స్ అంటే? సేమ్ అంటే? సేమ్ అంటే నెంబరా? సేమ్ అంటే మీ లాంగ్వేజ్లో నెంబర్ ఆఫ్ ఎలిమెంట్స్ సేమ్ ఉంటే సిమెట్రికల్, డిఫరెంట్ ఉంటే ఓకే. మ్యాట్రిక్స్ తెలియదు, మ్యాట్రిక్స్ రాదు, అప్పుడు హలో మ్యాట్రిక్స్ లేదు అది తెలియదు. ఇంకెక్కడ వెళ్ళే? స్కూల్ డేస్కి వెళ్ళండి బ్యాక్. స్కూల్లో ఒక టాపిక్ ఉంది, 7th 8th 9th నాకు గుర్తుకులేదు. ఎస్, so no superimposed. సిమెట్రీ. అమ్మా సిమెట్రీ గురించి ఆలోచిస్తున్నావా? చెప్పు. ఎస్, షేప్ సేమా? ఇప్పుడు ఆ టర్మ్స్ వద్దు, ఇంకా ఫిజికల్ ప్రాపర్టీస్ సేమ్ ఉండాలా డిఫరెంట్ ఉండాలా? సిమెట్రీ అంటే డిఫరెంట్ ఉంటే ఒక ఎగ్జాంపుల్ ఇవ్వండి మరి. సేమ్ ఉన్నది ఒకటి ఎగ్జాంపుల్ ఇవ్వండి మరి. అంటే సేమ్ 1 1 2 2 3 3 ఉంటే సేమ్ అనాలా? రైట్, హీ ఈజ్ వర్కింగ్. గుడ్. స్టాండ్ అండ్ షో. స్టాండ్ అండ్ షో. గుడ్ బాయ్. రైట్, హీ టుక్ one paper, he folded the paper and showing that. Continue now. Louder. గట్టిగా. నువ్వు నీ ఫ్రెండ్స్కి చెప్తున్నావు, నాకు కాదు. చెప్పిగా. ఇట్లానే బదులు వర్డ్స్ చెప్పు, అయిపోతుంది. స్పీక్. Okay, I will draw the diagram so that you will get an idea. This is a paper. What he want to explain, that I am saying. This is a paper he took. He folded the paper into half. He folded the paper into half. Then automatically, if you remove the folding, if this is the line, above and below, same or different? So it is a symmetric that you want to say it, correct? Okay, internal spacious symmetry we are going to say in crystalline solids, which is going to miss in amorphous. Good, nice. So that's thinking I want from you. So always don't clap hands for others. Others must clap for you also. When you will take that opportunity, that day will not come. Right. Spatial symmetry. What's the meaning of spatial symmetry? Space between the atoms. Type in the internal spaces symmetry we are going to see in crystalline solids, which is going to miss in, ante for example, gap between desk and desk. Same gap untada, different gap untada? Very different, yes, different ఉంటుంది. జనరల్గా అరేంజ్మెంట్ ఎట్లా ఉంటుంది? సో ఇంటర్నల్ స్పేషియస్ సిమెట్రీ. ఇదే డెస్క్లు బయట ఓపెన్ స్పేస్లో పెట్టేసి సమ్ ప్రోగ్రామ్ అవుతున్నప్పుడు అరేంజ్మెంట్ విల్ బి లైక్ దిస్. ఎవరికి వీలైనట్టు వాళ్ళు వేసేసుకుంటారా లేదు? సో ఇంటర్నల్ స్పేషియస్ సిమెట్రీ ఇస్ గోయింగ్ టు బి దేర్. ఓకే, రైట్. నౌ వెన్ యూ break a crystalline solids, you have broken a solid which is crystalline. The pieces that you are going to see will have regular shape. Generally ఇప్పుడు nowadays గ్లాస్, బస్సెస్కి గ్లాస్ ఉంటాయి కదా, తెలుసు కదా, డ్రైవర్ ముందర ఉండే గ్లాస్. ఓల్డ్ గ్లాస్, న్యూ గ్లాస్ డిఫరెన్స్ ఏంటి? ఓల్డ్ ఇఫ్ యాక్సిడెంట్ అయితే ద గ్లాస్ ఈస్ గోయింగ్ టు బి బ్రోకెన్. Big size pieces, and they are very sharp. Those pieces, if they are hitting the passengers, they may be facing problems. Sometimes death may also happen. But now the technology is changed. If suddenly a glass is going to be broken, all pieces will be of similar size and they will fall on the ground. Did you notice or not? I don't know. Ekkada accident aithe chudandi, చిన్న గ్లాస్ పీసెస్ ఉంటాయి, సేమ్ సైజ్ ఉంటాయి. Symmetry, crystalline solids will show that one. But old one, ఇప్పుడు ఇంట్లో మిర్రర్ ఉంది, ఓకే, బ్రేక్ అయితే ఈక్వల్ సైజ్ బ్రేక్ అవుతాయా? డిఫరెన్స్ ఉందా లేదా? సో దట్ ఈస్ ద థర్డ్ డిఫరెన్స్. Crystalline solids, when they are broken, the broken pieces will have a regular shape. Then what about here? Regular means opposite of regular. Irregular shape means small, big, different sizes. Okay na? Right. Next, because of this regular arrangement, these are called anisotropic. These are called isotropic. Anisotropic means what? Isotropic means what? Iso means what in general terminology? Iso means same. Okay, means different direction, same properties we can say it in the case of amorphous. Whereas different as the direction is changing, its properties are also going to change. We can call as anisotropic. Okay, because of regular arrangement, in one direction 3 atoms, in one direction 4 atoms, like that it will come. Irregular we can't say. So we used to say that they are isotropic in nature. Example for this is copper, silver, diamond. Copper, silver symbol, Ag, diamond, etc. In this case, glass, plastic, rubber, etc. So these are the some major differences between crystalline solids, amorphous solids. Okay na? Sir, what are you thinking? Then, right. Now, before learning about different types of crystal systems, like simple cube, BCC, FCC, etc., some technical terms that are used that we have to know. Already I said just now. Right. some definitions, like first definition is lattice point. What is lattice point? Already just now I said before this differences. Inside crystal, we can locate atoms, molecules, ions, etc. Where we can locate, that point is called as lattice point. Okay, right, what I can say? The position of atom or molecule in the crystal is nothing but called as lattice point. Student, I can find in the classroom on the chair or desk. Yes or no? In the same way, in a crystal, atoms or molecules or ions, where we can find, that point is called as lattice point. Okay. Then after this, space lattice. What is space lattice? Yes. It is space lattice, infinite three-dimensional arrangement of lattice points. This is one point where I can find atom or ion, that point I named as lattice point. Like that, many lattice points we can see. Extended three-dimensionally. Extended, this is two-dimensional picture, three-dimensional picture. It is a two-dimensional picture, three-dimensional picture. It is a two-dimensional picture, x-axis, y-axis. So set of lattice points, extended three-dimension, we call as space lattice. Okay, where inside crystal, where we can find atoms, only one atom will be there in a crystal, many atoms will be there. Where I can locate at lattice points. In 3D, that's all lattice points, what we have to say? Space lattice. Next, basis. What is basis? See, we have got different types of crystals, or different names are given, like classrooms I took. One is CSC, the other one is AML, one is civil, mechanical, like the different names we give. Yes or no? When we give these names, who is occupying that particular classroom chair, particular lattice point, what we keep, that name will be given, or name, chair name only given. This classroom, chairs are fixed. In that chair, if CAC students are sitting, then we say it is CAC classroom. If civil student is sitting, civil classroom. Means this classroom is named based upon the people who are occupying the chairs. Crystal, inside crystal, lattice points. So which lattice? That lattice point is occupied by some atoms or molecules or ions. Then that particular structure, shape you are going to get it or not. That is called as basis. Means if this is space lattice, if I keep some circles, then I'll get so I got final picture. Space lattice is filled with circles. Yes or no? So this is what? Basis. And this is what? Space lattice. So finally I'll get this is called crystal structure. Crystal structure. In the place of circle, if I take box, pattern will be same. Which type of pattern I'll get? This type of pattern we will be getting or not. So this is one crystal structure, both are same. So difference how? Based upon the basis. Okay. So assembly of atoms which are identical in composition, arrangement and orientations we call as a basis that will decide the crystal structure. Okay. Right. Next. Another term that you must know is about a unit cell. Another term regarding this crystallography is unit cell. What is unit cell? Why we have to study this? Generally, one example I will take. You want to construct one wall. You want to construct one wall. Generally, what you use in major quantity? Bricks. Now, generally, what is the shape of the brick? Rectangular in shape, cuboid in shape, or cube in shape? Cuboid in shape. When they are piled up, one above the other, if they are piled, you know what is the meaning of piling? Keeping one above the other. Final structure will come. Which type of picture it will be? Similar to the brick or different? Similar to the brick, the difference in terms of dimension. అంతే కదా, డైమెన్షన్ మారుతుందా లేకుంటే టోటల్ ప్రాపర్టీస్ మారుతాయా? డైమెన్షన్ ఈస్ గోయింగ్ టు చేంజ్. సో one wall is constructed. You must know its quality. You must know the wall quality. How the wall quality will be? It may be good or it may be bad. How you say, or when you say it is good or when you say it is bad? ఎప్పుడు చెప్పొచ్చు? ఎట్లా చెప్పొచ్చు? How you say that it is good in quality or not good in quality? ఎప్పుడు చెప్తారు? ఏం చేయాలి? వాల్ కన్స్ట్రక్షన్ చేసినాక ఎక్స్పెరిమెంట్ చేయాలా? ఏం చేస్తాం ఇప్పుడు? యూ వాంట్ టు కన్స్ట్రక్ట్ వన్ హౌస్ ఇన్ ఫ్యూచర్, యూ ఆర్ డూయింగ్. ఏం చేస్తారు? బ్లైండ్గా ఫోన్ చేసి సెండ్ బ్రిక్స్ మేషన్కి ఇచ్చి, ఆ పర్సన్కి ఇచ్చేసి కట్ అని చెప్తారా? ఏం చేస్తారు? వాట్ యూ విల్ డూ? You will be checking the quality. For that purpose, what you will do? దానికోసం ఏం చేస్తారు మీరు? ఏం చేయరా? ఏం చేస్తారు చెప్పండి? You will be approaching the person who is selling the bricks. అంతేనా? తర్వాత ఏం చేస్తాడు? ఆ brick seller, he will show you different qualities of bricks. Then, by seeing you are going to decide. ఏం చేస్తారు? The person who is selling the brick, he will say, these properties are different, these properties are different, black sheet is different here. He will say. Then he will show also. He will say and he will show. అంతేనా? చెప్తాడు, తర్వాత చూపిస్తాడా లేదా? వన్ ఆఫ్ ద మెథడ్ ఈస్ బ్రేకింగ్. జనరల్గా ఏం చేస్తారు? బ్రేక్ చేస్తారు. అంటే రెండు చేతులు పట్టుకు ఇట్లా విరిచేస్తారా? జనరల్ ఏం చేస్తాడు? యాజ్ పర్ మై నాలెడ్జ్ బ్రిక్ తీసుకుని పైకి వేస్తాడు. ఎంత పైకి వేస్తే అంత పైనుంచి కింద పడుతుంది కదా. పడ్డాక ఇఫ్ ఇట్ ఈస్ బ్రేకింగ్ ఇన్ టు పీసెస్, సమ్ విల్ బికమ్ పీసెస్, సమ్ బ్రిక్స్ విల్ నాట్ బికమ్ పీసెస్, డిపెండ్స్ అపాన్ ద పైల్. సో విచ్ ఈస్ నాట్ బ్రేకింగ్ ఇన్ టు పీసెస్, దట్ ఈస్ గుడ్ క్వాలిటీ వన్. ఫర్ లెస్ హైట్, కొద్ది హైట్ అయ్యగానే పడిపోయింది, పీసెస్ అయిపోయినవి, దట్ ఈస్ లెస్ క్వాలిటీ వన్. అది వన్ మెథడ్. ఇంకో మెథడ్ ఏం చేస్తాడు? హీ విల్ గివ్ యూ వన్ బ్రిక్ అండ్ హీ విల్ సే దట్ కీప్ దిస్ బ్రిక్ ఇన్ వాటర్ ఫర్ 2 or 3 days. After 2 or 3 days, if brick shape is as it is good quality. But if it is melting అంటే తెలుసు కదా, కరిగిపోవడం. If it is melted in water, automatically it is, or sometimes కొద్దిసేపు డిప్ చేసి ఆఫ్టర్ వెట్టింగ్ హిట్ ఇట్. ఫర్ స్మాల్ ఫోర్స్ ఇట్ ఈస్ బ్రేకింగ్, ఫర్ లార్జ్ ఫోర్స్ ఇట్ ఈస్ బ్రేకింగ్. స్మాల్ ఫోర్స్కి ముక్కలు అయిపోయిందంటే లెస్ క్వాలిటీ, heavy force ki, if it is becoming pieces, strong. So with that we will come to conclusion that this brick's quality is so and so. Antena? Or each and every brick you are going to test it? Or else another example is your mother is cooking food. ఇంట్లో అన్నం వండుతుంది. అన్నం అంటే తెలుసు కదా, రైస్ కుకింగ్ చేస్తున్నారు. షీ వాంట్ టు నో వెదర్ రైస్ ఇస్ కుక్డ్ ఆర్ నాట్. షీ వాంట్ టు నో వెదర్ రైస్ ఇస్ కుక్డ్ ఆర్ నాట్. వాట్ షీ విల్ డూ? షీ విల్ చెక్ ఇట్. హౌ? స్కాన్ చేస్తుందా? ఏం చేస్తుంది? ఫస్ట్ షీ విల్ మిక్సప్ చేసి షీ విల్ పిక్ వన్ గ్రెయిన్. షీ విల్ డూ సంథింగ్ లైక్ దిస్. సమ్ క్లారిటీ షీ విల్ కమ్. దెన్ if you want to continue, she will continue the flame on flame, or else she will keep on away from the flame. Antena? Or ఒక్కొక్క గ్రెయిన్ తీసుకొని ఓకే రైట్ కుక్డ్, నాట్ కుక్డ్, like that she will do. So one single piece, with that piece she will come to conclusion regarding the food, whether it is cooked or not. That single piece is nothing but called as unit cell. So what is unit cell? The fundamental building block. The fundamental building block. By repeating in 3D, we get final crystal structure, and which gives complete information about the crystal. That one we call as unit cell. It is a fundamental building block. Okay. By studying the properties of the unit cell, we can guess about the crystal. Yes or no? That unit cell is part of one crystal. So what are the properties of crystal means? We have to break the crystal into pieces, and we have to check, and we have to come to conclusion. We take unit cell of the crystal, we study the properties. That properties we can implement for entire crystal. So what you took, that is called as unit cell, fundamental building block, I can say it. Okay. So smallest block which gives entire information about the crystal, and by building up final crystal structure we are going to get it. That is called as unit cell. That also gives properties, shape also. The same, if you take a cube shaped, keep one above the other, cuboid shape, cube like this. I am drawing 2-dimension picture. Four. Okay, itlante some confusion will come. This I want. No need. Okay. This is about a unit cell. Next, after this, lattice parameters. So what are lattice parameters? The other technical term related to crystallography is lattice parameters. So what are lattice parameters? Lattice parameters are nothing but A, B, C, alpha, beta, gamma. These are called lattice parameters. So what are they? A, B, C, alpha, beta, gamma. A, B, C's are called as primitives. And alpha, beta, gamma, angles, interfacial angles. Primitives, interfacial angles, together we call as lattice parameters. What are they? A, B, C, alpha, beta, gamma, where A, B, C are called as primitives, alpha, beta, gamma are called as interfacial angles. Why? These terms we have to know. For example, this is one crystal, 3-dimension. Okay. This is another crystal. Can you find any difference between these two figures? Any difference is there? Yes or no? What difference you see in terms of its shape? I can also show like this also. All are crystals. all are has different shape. They have got different shape because I drawn. Without drawing, can we say? If you can say, how to say? Got my point? What I want to say? నేను ఏం చెప్పాలి అర్థమైందా? I drawn, by seeing that figure, you are saying that they are different in shape. Now if I without drawing, you can see different shapes of crystals. Define them means how? How to define? Some technical terms you have to use it or not. By using them we can define it or not. Those technical terms are what? Lattice parameters. అర్థమైందా? So lattice parameters are used to describe the shape of the crystals. Okay, 7 crystal systems we are going to see, divided into 14 previous lattices. So those 7 systems, in what way they are different means difference in terms of lattice parameters, nothing but in terms of A, B, C, alpha, beta, gamma, where A, B, C are called as primitives. Primitives are nothing but what? That crystal, it is a 3-dimensional picture. It has got x-axis, y-axis, z-axis. Now some number of units along x-axis, similarly y-axis, z-axis we are going to take that information. Okay, right. So this are used to describe the form and size of the unit cell. Primitives, lattice parameters are used to describe the form as well as size of the unit cell. Okay na? Right. So first what we seen? First one, lattice point. Then afterwards, space lattice. Next, crystal structure. How a space lattice convert into crystal structure? By arranging of atoms, molecules, ions. That one we named as basis. Then the crystal properties I want to study. Crystal properties I want to study. Means entire crystal I have to break. అయిపోయింది, కవర్ అయిపోయింది. అయిపోయిందా? ఏమొచ్చింది? ఏం చూస్తున్నావు? చేతిలో ఏముంది? ఏమి చూడండి, ఇట్లా చూస్తారా? ఏం లేదు అక్కడ. నీ మొబైల్ ఎక్కడుంది? మరి కింద ఏం చూస్తున్నావు? మరి ఏం చెప్తున్నా చెప్పు. ఏమేమి చెప్పాను చెప్పు. Okay, tell me about unit cell. Good listening. Tell me about unit cell. Why we have to study unit cell? ఎందుకు చదవాలి యూనిట్ సెల్? ఎందుకు చదవాలి? Okay, to study the properties of crystal you have to take unit cell and okay, good, right. So unit cell tarvata lattice parameters, all related to crystals or other than crystals? All are related to crystals only. Okay, I need some water. Okay, sorry for the disturbance. So we have got different crystals. Different crystals we can express in terms of lattice parameters. Okay, what are those lattice parameters? 3 primitives, 3 angles, alpha, beta, gamma. Crystallographic axis, alpha, beta. Alpha is the angle between x and y axis. Means if I take this crystal, if I extend like this, if I draw lines parallel to the planes, x axis, y axis, z axis, angle between x and y is alpha, y and z is beta, z and x is gamma. Now some units will be there along x axis, y axis, z axis, a, b, c. Now u times a on x axis, v times b on y axis, w times c later on we are going to take. Means how many times we repeat it, how many times we repeat it along x axis, u times a. Okay, so u is a number, it may be 1a, 2a, 3a like that. V, w, u, v, w are the integers. Okay, 1, 2, 3 for right. With respect to x axis, with respect to y axis, with respect to z axis, for that purpose we write 1a, 2a, 3a like that. A related to x, b related to y, c related to z axis. Angle between the planes means we have to draw lines parallel to the planes. Some angle is going to form, those angles we call as interfacial angles. Okay, na? Right. So unit cell. Next. So some idea we got regarding what is the meaning of crystal, the technical terms that we are using. Next we are going to see primitive cell. The next term that we are going to see is primitive cell. What is primitive cell? What is primitive cell? It is also called as unit cell. When it is called as a unit cell, some conditions it must satisfy. That the total number of atoms must be equal to 1. In that cell, how many atoms it must have? 1 atom. The total number of atoms must be equal to 1. Next, the second condition is the atoms must be located only at the corners. The atoms must be located only at the corners. Such cell is nothing but called as primitive cell. What we say? Means how many lattice points will be there in primitive cell? 1 lattice point. Means how many atoms? 1. Let us draw. Just I am drawing 2-dimensional picture. This is a unit cell. Okay, right. These are the atoms that I can find. Now, let us see whether it is a primitive cell or not. How many atoms must be there in the unit cell? 1. But here how many atoms are there? 4. Right. I will draw another figure, 2-dimensional figure. That is also same, dimensions are same. The only difference is what? Number of atoms. Here in the first figure 4 atoms, I can locate at 4 corners. Whereas there, what I can see? Atom at the center. Now tell me it is a primitive cell or not. Which one is a primitive cell? If I say this is A and this is B, so which one is a primitive cell and why? Condition is what? How many atoms must be there total? 1. So in which figure 1 atom is there? B or A na? Both are. How? In A figure how many circles are there? How many atoms are there? In second figure how many are there? Then? Yes? Corner means? Say. Corner atom means? Okay, you are near to the point. You are near to the answer. Observe and say. See and say. See how he is hiding his face. Why you kept your back like this vertically? Sitting in the first row. Great. Did I ask anything else about these pictures? What? Louder. Speak loudly. ఫస్ట్ డెస్క్లో కూర్చున్నావు ఎట్లుండాలి సే సే అంటే సిట్ ఇంగ్లీష్ పూరా దెన్ సే అంటే కూర్చుంటున్నావు ఏమండాలి సరే స్పీక్ నో టెల్ మీ ఇన్ వాట్ వే బోత్ ఆర్ డిఫరెంట్ See and say. A is a primitive cell, non-primitive cell. B is a. So your both answers are wrong. I'll say. Then go for second option. A is. B is. Don't know. A is a primitive cell. B is a non-primitive cell. How? What is the condition? How many atoms must be there in the unit cell? But how many atoms are there? Then how 4 will become 1? Amma? Yes, good. Contribution is how much? Total circle, how much portion is part of this unit cell? 1 by 4. This portion is 1 by 4. 1 by 4. 1 by 4. How many 1 by 4s are there? So total is equal to how much? 1. Why we have to take 1 by 4? Because I drawn 1/4. అదే ఎందుకు 1 by 4? ఎందుకు 3 by 4 నెగ్లెక్ట్ చేయాలి? నో డిగ్రీస్. డిగ్రీస్ అనే పదం లేదనుకుందాం. నో యాంగిల్స్. గుడ్. What you see? Just now what I drawn? Is it visible? Right. Okay. Right. అర్థమైందా ఏమన్నా? Understood? So tell me now. Express in words the diagram. This one you expand. It is a 3-dimensional. I can't have fully a portion I drawn. From that portion, a small unit cell I took. This is what? This. If I took unit cell. The unit cell is this one. Okay, na? Then see this atom. How much portion is there? సేమా ఎన్లార్జ్డ్ పిక్చర్ అర్థమైందా డయాగ్రామ్ మీన్స్ దిస్ ఈజ్ వన్ ఆటమ్ షేరింగ్ విత్ హౌ మెనీ యూనిట్ సెల్స్ 1 2 3 4 each atom is sharing with 4 unit cells in 2 dimension it is. So what is the contribution of that atom with each unit cell? How much portion? This 1/4th, another one, this one, another one, this another unit cell in 2D. So that's why 1/4th we took. If you take 3D, if you take 3D, tell me 3D, imagine the picture. This classroom is a cube. Think. I'll take one corner. Tell me if like this continuous rooms are there, this plane, back side also, that corner, upside, downside, all 3 dimensions. Okay, rooms are there, one room, another room, another room, another room, upside also one room, there one room, that side also. One corner common to how many rooms? Think and say. It is common to, in the place of room, think it is unit cell. And at that corner you take an atom. So contribution of atom to you, each cell will be how much? 1/8. 1/8. Why we have to take 1/8? If someone will ask, then what you will say? This answer you will say. In 2D we take 1/4. In 3D we take, means that that atom sharing with 4 atoms in 2D, 4 unit cells in 2D, 8 unit cells in, how 8? This is one room, second room, third room, fourth room. In this place, the same combination we can say upside or not. So for all 8 rooms, that corner is common or not? If I find any atom, that atom I am finding in all 8 rooms, so what will be the contribution? 1/8. So in 2D 4 atoms, 4 corners, but total atom will be equal to 1, because in 2D the contribution 1/4th, in 3D the contribution is 1/8. So 8 into 1/8 is how much? 1. So how many atoms are there here total? And where the atoms you can find? Corners. So it is called as a primitive cell. Here one atom is there, inside the unit cell it is a non-primitive cell. Sometimes in the unit cells of an atom, of a crystal, may contain more than one atom, 2 atoms, 4 atoms, like that. Then what we say about those? They are called primitive cells? No. Primitive means how many? Only one atom. And where we have to find them? Only at the corners. If more than one atom, if you are finding, what we have to say? Non-primitive cell we have to say. Okay, na? Right. So simple cubic crystal, and other one is primitive cell. Unit cells will be same or different? It will be same that we are going to see later on. Next, other term that we are going to see is lattice parameter. Lattice parameter. Sorry, sir. Lattice planes. Lattice planes. What are lattice planes? The plane which is formed by joining lattice points. Lattice plane is a plane formed by joining lattice points. those planes are called as lattice planes. See, what are these dots represent here? Each and every dot is lattice. When you extend in 3D, when you extend the dots in 3D, what we said? Space lattice. Now what I do? For what purpose we drawn dots? Where we see these dots? Inside the crystal. What, for what purpose? Where we can locate atoms, molecules, ions of that particular crystal. That is called as lattice point. Now see, I drawn one line by joining lattice points. These lines are called as lattice planes. Those are called as lattice planes. So it may be horizontal, it may be vertical, it may be slant with one positive slope, the other one is negative slope. Which will be positive, which will be negative? This line will have positive slope or this line will have positive slope? Upward slope is, downward slope is, I think reverse, y2 minus y1 by x2 minus x1. Okay, so these are called as lattice planes. How these lattice planes are formed? By joining lattice points. Okay, now this is one lattice point, this is another lattice point. Yes or no? There is a gap between these two lattice points. This is called lattice constant. What we say? Lattice constant. The distance between two lattice points. What we say it is? Lattice constant. Lattice constant for a particular crystal will be same or it will be different? It will be same. If crystal changing, it might be changing, but it is same. Now, this is one lattice plane. This is another lattice plane. Some separation we can see it or not. Some separation we can see it or not. This is interplanar spacing. Interplanar spacing indicate with letter D. The space that is present between two planes of a crystal, that we call as interplanar spacing. Later on, this D is given as A by under root of h square plus k square plus L square. Expression for D in terms of A and HKL. Here what is used? H square plus k square plus L square. H, K, L. These are called as Miller indices. These are called as Miller indices, which are used to describe the planes of a crystal, and the crystal planes are formed by joining the crystal points, lattice points. The distance between two lattice points is lattice constant, and the gap distance between two lattice planes is interplanar spacing, and expression for D is what? In terms of A and HKL. In terms of lattice constant and Miller indices is D is equal to A by under root of h square plus k square plus L square. This derivation you are going to see later on. Okay, na? Right. So lattice points, lattice planes. There are, in theory, there are 320 space lattices. How many are there? 320 space lattices are there. These are divided into 32 classes. As per theory, how many space lattices are there? 320 types, and they are classified into how many types? 32 classes. And these 32 are arranged in 7 crystal systems. 32 arranged as 7 crystal systems. So what are those 7 crystal systems? The 7 crystal systems will be like this. Cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral, and the last one is hexagonal. Seven crystal systems. What are they? Cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral, hexagonal. These are the 7 crystal systems. Okay. 7 crystal systems. What are they? Cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral, hexagonal. Right. How these 7 crystal systems are different? In what way they are different? In what way the 7 crystal systems are different? How to differentiate them? How to differentiate them? By drawing diagrams. Yes or no? Already 3 diagrams are run previously. Like that, how many are there? 7. One method. Another method is what? One is by drawing, that you can say. But after drawing also, we have to express it. So to express about a crystal, we use lattice parameters. Means we can show the difference in terms of lattice parameters. What are those lattice parameters? A, B, C, alpha, beta, gamma. So A, B, C, alpha, beta, gamma values will be same for all 7. It will be different. Yes or no? Right. A is equal to B is equal to C. Alpha is equal to beta is equal to gamma is equal to 90. What happened, boys? Excited, exhausted? Excited? Who is speaking? You, myself. Who is speaking? Yourself, myself? Huh? Author. Who is standing? Yourself, myself? Author. Then who must feel exhausted? Yourself, myself? That don't say author now. I think up to what? 12 only, na? Up to 12 gada? What is the time now? 11:20, no problem. More 40 minutes again. Right. A, B, C equal, alpha, beta, gamma equal and equal to 90 degrees. Means how the diagram will be? X-axis, Y-axis, Z-axis. What is A? Primitive on X-axis. What is B? Primitive on Y-axis. What is C? Now if I draw one line, same dimension, different dimension? Same dimension. And this angle is 90. This angle is 90. This angle is also. This is alpha, beta, gamma. Is there a example is polonium, sodium, mercury, polonium, sodium, rm, silver, etc. Example for simple cubic structure. Which elements are example? Polonium, sodium, Rm, lead, etc. And what is simple cube? Where A, B, C are equal, alpha, beta, gamma will be equal to 90 degrees. Means if you develop the crystal, how it looks? Okay. So what is this angle? 90, 90, 90. This length is 1 unit. This length is also 1 unit. This length is also 1 unit. A, B, C are equal. Alpha, beta, gamma is equal to 90. So this is which type of cell? Cubic cell. Okay. After cubic, tetragonal. What is tetragonal? A is equal to B, not equal to C. Alpha is equal to beta is equal to gamma is equal to 90. Means what will be the different? Titanium oxide, tin oxide. Example is titanium oxide, tin oxide. So how the picture will be? Imagine. Shall I draw this type? I'll draw this type so that you can develop this. Okay, how it looks? See, same, some difference you can notice that or not? A, B's are equal but not equal to C. A and B are equal but not equal to C. Alpha, beta, gamma is equal to 90. Means how it looks? Imagine. So example is titanium oxide, tin oxide. Next, orthorhombic. So what is orthorhombic? A not equal to B, not equal to C, and alpha is equal to gamma is equal to 90 degrees. Primitives are of different size. Example is lead carbonate, barium sulfate. Lead carbonate, barium sulfate. How it looks? Tell me. This is A, this is B, this is C. Same? Same? This figure, this figure, this figure, same? So this crystal, this crystal, this crystal will be different. How? In terms of lattice parameters. Here A, B, C are equal. Here A and B equal, not equal to C. Here A, B, C are of different, but angle in each case is 90 degrees. Examples also great. Next, monoclinic. What is monoclinic? A not equal to B, not equal to C. Alpha, beta is equal to 90 and not equal to gamma. Antena? See the difference. Here all are equal. Second stage only one is different. Third stage all three are different. Fourth stage all three are different. Two angles are 90. Third angle is not equal to 90. And example for this is calcium gypsum. Gypsum formula? Calcium sulfate with 2 molecules of water. Calcium sulfate with 2 molecules of water. I know that you know. You are not watching movie to see and enjoy. No pen, no book. Remaining they are writing. What you are doing by sitting in the front desk? This also you want to copy from them, huh? Then why are you not writing? Okay, sir, I'll give pen. Come and write on the board. Go pole. Okay. Then after this, triclinic. So what is triclinic? Same in order. A not equal to B, not equal to C. Alpha not equal to beta, not equal to gamma, not equal to 90 degrees. Primitives are of different dimension. Angles are also different and not equal to 90. Example is copper sulfate with 5 molecules of water. What is the color of copper sulfate with 5 molecules of water? Which color it will be? Which color? Blue color. Copper sulfate with 5 molecules of water salt, in what color it is available? Blue color it will be. Okay. Crystallization of water concept. Inside salt, water will be there. Means the salt will be in wet condition. It is in dry. Then how? The color will be blue color. If you heat that, water will be evaporated. Then it changes into colorless powder. Crystallization of water concept. You studied in 10th class. Okay. So triclinic is what? A, B, C primitives are of different dimension. Angles are also different. And not equal to 90. Example is copper sulfate with 5 molecules of water. Right. Next, rhombohedral. A is not equal to B, A, B, C equal. Okay. A, B, C are equal, and alpha, beta, gamma not equal to 90 degrees, but less than 120 degrees. But less than 120 degrees. Example for this is calcite, arsenic, calcite. Calcite, have you heard about this word? Winner eppadana? It is used in the preparation of prism, calcite, quartz prism, calcite prism ani. Prism, you know, where it is used? To explain what? Prism is used to explain what? Ma? Use antunna. Use prism use ekkada? Refractive index ante? Okay, refractive index anna. What is refractive index? N, small n, R, mu na. In some books mu antaru, in some books small n antaru, in some books R dot I antaru. What is refractive index? ఇంకొన్ని బుక్స్లో ఎట్లా కూడా ఉంది. N is equal to, what is C, what is V? Velocity of light in air. Velocity of light in a medium. In air it is C, in medium it is V. The ratio between speeds of light in air to medium we call as refractive index. Means light, when it is allowed to travel in a particular medium, particular velocity. Clear? The same light, when it is allowed to move in different medium, same velocity, different velocity. Velocity is also going to be different. As the velocity is changing, what is going to change? When the light velocity is changing, what is going to change? When the velocity is going to change? When the light velocity is going to change? Just now I said na, medium changes. Why? Why the light velocity has to change when there is a change in the medium? Medium changing means density of the medium is also going to change. So automatically lighter density is faster with the heavy density. So as the density is changing, what is going to change? Velocity is changing. Maladanakandi. Again one more change we can notice. Think and say. Huh? Abbo. Inka. Intensity. ఇంకా మీకు సైకిల్ వచ్చా? అందరికీ టూ వీలర్ నడపడం వచ్చా? సైకిల్, బైక్ ఎక్సెట్రా. ఓకే, మీరు ఫాస్ట్గా పోతున్నారు, సడన్గా డ్యామేజ్ స్టార్ట్ అయింది. ఏం చేస్తారు? ఇమీడియట్గా అదే స్పీడ్ మెయింటైన్ చేస్తారా? బ్రేక్ వేస్తారు. అంటే ఆగిపోతుందా? స్లో అవుతుంది. స్లో అవుతున్నప్పుడు ఇంకేం చేంజెస్ కనిపిస్తాయి? రేపు బండి నడుపుతున్నారు కదా, ఎప్పుడు గెస్ చేయాలి, ఆలోచించండి. స్పీడ్ మార్చారు, డిక్రీజ్ చేశారు స్లోగా, అప్పుడు ఏం మారుతుంది? గేర్ మారుతుందా? ఆహా. ట్రావెలింగ్ టైం మారుతుంది, గేర్ మారుతుంది, ఇంకా స్పీడ్ మారుతుంది, ఇంకా చెప్పండి పర్లేదు. నేను చెప్తే ఒక నిమిషంలో అయిపోతుంది, ఒక సెకండ్లో అయిపోతుంది. మీరు చెప్తే కొన్ని టర్మ్స్ వస్తాయండి నాకు, అంతే. మీరు 2 వీలర్ నడుపుతున్నారు ఇప్పుడు, ఇమాజిన్ చేసుకోండి. సడన్గా స్పీడ్ డిక్రీజ్ చేశారు, ఏం మారింది? ఇమాజిన్ చేసుకోండి. అక్కడ ఆయన ఇమాజిన్ చేస్తున్నాడు ఫోన్లో. ఏం చేస్తారు సార్? ఏముంది చేతిలో? అన్నీ మాయమైపోతాయి. కానీ పెన్, డెస్క్ మీద పెన్ పెట్టావు, లెఫ్ట్ హ్యాండ్ ఎక్కడుంది? మరి నేనేం అడిగాను చెప్పు మరి. సరే, నాకు వచ్చి స్టాండ్. గుడ్ నేమ్ ప్లీజ్. బ్లూ కలర్ షర్ట్. బ్లూయేనా? వాట్స్ ద గుడ్ నేమ్? इरफान. बोलो. हिंदी आता नहीं आता? हाँ चलो, मैं क्या पूछ रहा हूँ? कुछ भी नहीं. आप क्या कर रहे हैं? कुछ तो कर रहे हैं. तो आप क्या सुन रहे हैं? ये क्या सुनना? ये भी रहता क्या? से इन वर्ड्स. क्या सुने? हाँ, समझा नहीं. వచ్చినాక నువ్వు కూర్చున్నాక ఏం విన్నావు? నాకు తెలిసి నేను అడిగే క్వశ్చన్ కరెక్ట్ అని నీకు తెలుసు, నువ్వు నిజం చెప్పలేకపోతున్నావు, అంతేనా? ఇప్పుడు చెప్పు, మరి ఏం చేస్తున్నావు? సార్ ఇర్ఫానా? ఇర్ఫాన్ సార్ చెప్పండి. మీరంతా ఊహించండి, బైకు డైరెక్షన్ స్లోగా వెళ్ళిపోయారు. ఏమైంది? యాక్సిడెంట్ అయిద్దట. గ్రేట్. ఇప్పుడు నా నోట్లోకెళ్ళి వచ్చింది. ఏమవుతుంది? హ్యాండిల్ పట్టారా? స్పీడ్ డిక్రీజ్ అయిందా? స్లో అయినా కూడా అట్లే ఉంటుంది హ్యాండిల్. ఏం చేస్తారు? డైరెక్షన్ అనేది ఏమవుతుంది? సేమ్ ఉంటుందా, మారిపోతుందా? इरफान, गाड़ी चलाना आता? चलाए? फास्ट स्लो? बैठ जाओ. मालूम लॉजिक आंसर्स देके मैजिक करते बोल के क्लास में. कुछ काम का नहीं रहता वो मैजिक. डन. So as the speed changes, direction is going to change. That is nothing but deviation, we used to say. What we used to say? Deviation. How much amount of deviation? How much direction change? How much change in the velocity? Got my point? That is expressed in terms of refractive index. Understood? Means medium property will decide the velocity. So all particles that you come across, all material that you come across has got same density. Difference is there or not? క్యాల్సైట్ ప్రిజం, క్వార్జ్ ప్రిజం. ఓకే, ప్రిజం అది క్వశ్చన్ అక్కడికి వెళ్ళి వచ్చింది కదా. మీరు రిఫ్రాక్టివ్ ఇండెక్స్ అన్నాక ఇక్కడికి వచ్చాను నేను. సో వాట్ యూజ్ ఆఫ్ ప్రిజం? ఎక్కడ వినలే? చూసారా? హౌ యూ సీన్ ప్రిజం? హౌ ఇట్ లుక్స్? డిస్క్రైబ్ ఏ ప్రిజం. బేసిక్స్ అమ్మా, గుర్తుంచుకోవాలి. On a shiny day, sudden a shower comes. What we see in the sky? Because of what? Raindrops. Raindrops will act as a prism. White light, when it is passed through prism, it refract and splits into constant colors. Okay, done. So coming to the subject, calcite like that. Next, hexagonal. A is equal to B, not equal to C. Alpha is equal to beta is equal to 90, gamma is equal to 120 degrees. An example is quartz, zinc, cadmium. Quartz, zinc, cadmium. So these are 7 crystal systems. Okay, na? What are the cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral, hexagonal? How you are going to show variation in terms of A, B, C, alpha, beta, gamma? A, B, C are called as primitives, alpha, beta, gamma are called as interfacial angles. C. Any similarity, is there any variance in those 7? Any similarity we can find? So here you can say, sir, these two are same, sir. If these two are same, see here angles, it is same. If you say A is equal to B, these two are same, then what is different? Angles are different. Here angles are same, then what is different? Diamond primitives are different. Okay, na? So every crystal has got its own primitive as well as interfacial angles. Okay, so these 7 crystal systems according to Bravis. Bravis lattices. There are 14 ways of arranging the 7 crystal systems. How many ways? 14 ways. Who gave this? Bravis. In which year? 1848. In the year 1848, Bravis said that the 7 crystal systems can be shown in the form of 14 ways, called as 14 Bravis lattices. In what way they are different? For that purpose, you must know PIFC. You must know, before saying about Bravis lattices, you must know the meaning of PIFC. PIFC. What, sir? Coconut trees on the shirt. మీ ఏరియా కోకోనట్ ట్రీస్కి ఫేమస్ అని తెలుసు. ఇదంతా చుట్టూ కోకోనట్ ట్రీసే ఉన్నాయా ఏరియా? దానికి నువ్వు బ్రాండ్ అంబాసిడర్ ఇప్పుడు. మరి ఏముంది మరి? వాట్ ఐఎమ్ సేయింగ్? తర్వాత హౌ మెనీ? 14. గుడ్, వింటున్నావు. సో టు షో దెమ్ యూ మస్ట్ నో ద మీనింగ్ ఆఫ్ PIFC. What is that? What is the meaning of PIFC? What is C? Base centered cubic crystal. Base centered. What is F? Face centered. What is I? Body centered. And P, primitive. Means unit cells, inside unit cells atoms will be there. In what way you can arrange them? Either in the form of base centered, face centered, body centered, primitive. The 7 crystal systems may have all 4, or one among them, or 2 among them, or 3, but it is not necessary that all will have all 4 types. Okay. So before knowing about those 14, which crystal system has got which Bravis lattices, you must know meaning of PIFC. Without knowing them, we can't write. So already we discussed about this. We discussed or not? Where we discussed? While discussing the unit cell, we discussed about this. What it is? Primitive. What is the meaning of primitive cell? What is the meaning of primitive cell? Primitive cell means what? Where we find atoms? At the corners. Okay. So I'll draw 2 dimension as well as 3 dimensions, so that some information I'll give which will be used to write while writing simple cube BCC FCC. This is 3D. So what I do, I show simply like this. Clearly. Okay. So primitive cell, this is a primitive cell. Means what? In the unit cell, where we see atoms at the corners, lattice points. Okay, that is first point. Total number of atoms belonging to the unit cell is how much? 1. Even though 8 atoms are there, we take as 1. Why? Because each atom is sharing with how many other unit cells? 8 unit cells. So what is the contribution of each atom to each unit cell? 1 by 8. Like that, how many are there? 8 are there. So 8 into 1 by 8 is how much? 1. Okay, that is in the case of primitive cell. Okay, now next, body centered, means center of the body. Means if you take this is classroom, it's a crystal unit cell. Crystal's unit cell is this classroom. It is not a cuboid, but think it is a cube. What we see, along with 8 corner atoms, along with the 8 corner atoms, already same, both are same or not? The difference that you are going to see is one atom at the center of the unit cell. So center means like this. Imagine it's a 3-dimensional picture. One center at the, let us see shapes and the possibility on the. Include చేయాలి. Okay. So that central circle is middle. Here, what is the total number of atoms that we took? 8 into is equal to how much? In this case, or both are same? Tell me. 8 into 1 by 8 plus 1. How much it is? 1 plus 1 is how much? So total number of atoms of unit cell of body centered cubic crystal is how much? 2. Primitive cell is how much? Stand. ఏం చేస్తున్నావు ఇప్పుడు అవసరమా? కరెక్ట్ ఆన్సర్ చెప్పింది కనుక ఇక నో ఫర్దర్ డిస్కషన్. ఏమన్నా మెసేజా, ఫోన్ వచ్చిందా? అటెండ్ చేయి మరి, అర్జెంట్ అనుకుంటా. ఇప్పుడు నాకు ఫోన్ వచ్చిందా, అటెండ్ చేశానా రిజెక్ట్ చేశాను? నువ్వేం చేయాలి? అటెండ్ చేసినావు కదా, ఎమర్జెన్సీ. కానీ కూర్చో. నిజం ఒప్పుకోవడం కూడా ధైర్యం కావాలి, కానీ దాన్ని కంటిన్యూ చేయొద్దు. ఓకే, రైట్. ఇదేంటి సార్ చెప్పగలుగుతావు? ఇదేంటో మిస్టర్ 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 మితు 3 త్రినేత్ర, అబ్బో 3 కళ్ళవాడు, అందుకోసం ఫోన్ నడుస్తుంది అక్కడ. హౌ మెనీ ఆర్ దర్ హియర్? వాట్ ఇస్ దిస్? అరే వాడిని ఆలోచించనియండి. లెట్ హిమ్ యూజ్ హిస్ థర్డ్ ఐ. What information you get from that equation? Here one equation, that an equation. For what purpose I wrote? వినట్లేదు. Tell me. Friend, sitting beside him. No, this one. Help him. Help your friend. You are depending on him, huh? Pink color shirt is depending on white color shirt. Ipudu your name, sir? Shashi. Cheppiga Shashi. Em cheppala? Let us use white shirt. This equation I am asking. Means the unit cell of a primitive cell contains one atom. Sir, this picture, good, white sheet. This picture regarding which unit cell, which type? Body centered. Contains how many atoms? 2 atoms. Okay. Next. Next one is what? Face center. I prefer drawing so that I can increase my skill. If I depend on it, my drawing skill will be lost. Right. What is this? Primitive cell. Why? At corners only. Done. Now our discussion is about face centered. You must know what is the meaning of face and how many faces will be there in a cube. 6 faces. What are they? Left, right, top, bottom, front, back. Center of each face, one atom. So I will show a color difference. Okay. So 1, 2, 3, 4. Okay. Let us take see, not visible. ఏదో ఎక్స్ట్రా అయిపోతే ఎట్లా అవుతుంది? బ్లూవా, రెడ్డా? రైట్. ఇంకొక కలర్ ఏదో నాకు వచ్చింది. మీరంతా విఐపీస్ తెలుసు కానీ బ్లూ. Front red, back white. So total how many? Now total number of atoms belonging to this unit cell how much? How many corner atoms? Their contribution? How many face centered atoms? What is the contribution? Think and say. That corner sharing with 8. So each cell is 1 by 8. Now let us take one wall, this board. This is one face. This wall is common to how many unit cells? This wall is common to how many classrooms? In the place of wall, if I take a cell, it is common to how many unit cells? Contribution is how much? So 1 by 2. 8 cancel. 2 1s are 2 3s are. So 1 plus 3 is how much? 4. So primitive cell, total number of atoms in the unit cell? Primitive cell 1. body centered, face centered. The leftover one is base centered. What is the meaning of base centered? Base centered, center of base. How many bases will be there for a unit cell? One base. Okay, right. Let us take first. So base centered. How many bases will be there for this? One base. So this is base. But this plane also act as a base for the above unit cell. Yes or no? So I can take one more cell. One more atom there I can say. Yes or no? So that is nothing but what? Base centered cubic crystal. Tell me the total number of atoms which are there in that. How many corner atoms? Contribution? How many base centered atoms? Contribution? Total? 1 plus 1 is how much? 2. So we seen 4 types: primitive, body centered, face centered, base centered. Unit cell shapes we seen. And additionally what we seen? The total number of atoms of a primitive cell, body centered, base centered, face centered. So same number of atoms are there in all types of cells? Different or same? I shown you na. Primitive 1, face centered 4, body centered 2, base centered 2. Okay na? Right. Why? Because simple cube, BCC, FCC topics are there. In those topics we write number of units present, number of atoms present in the unit cell. What we have to write? Number of atoms present in the unit cell. For that purpose there we write. Here we are drawing and we are learning. Okay na? Right. But actually our discussion is what? What we are discussing? Brevis lattices. Okay. So cubic has got 3 types: PIF. Cubic crystal, how many types of unit cells does it have? One is primitive type, one is body centered, the other one is face centered. So what is not present? Base centered. Tetragonal has got P type, I type. In tetragonal, how many types? P type, I type. Orthorhombic, all 4 types: P, C, I, F. All 4 types. For which type of cubic crystal? Orthorhombic. For monoclinic, P type. For triclinic, C type, P type. C type, P type, and remaining P type. So 7 crystal systems. All crystals has got all combinations of unit cells? No, only one. Which one? Orthorhombic. Remaining selected. Now you count total. So total how many? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many Brevis lattices? 14 Brevis lattices. 14 Brevis lattices. Means A, B, C, alpha, beta, gamma 90, P type, primitive you know. I type means body centered means 2 atoms at the 1 atom at the center of the body also we can show. Face centered means 8 corner atoms plus 6 faces. Such that when you are drawing that, the dimensions of A, B, C must be equal alpha beta gamma must be equal to, I'll draw one so that you will get an idea. So first of all I am drawing 3 unit cells. Why? Because primitive has got 3 combinations, p type, I type, f type. Yes or no? Imagine that these dimensions are same. A, B, C values are same. A is equal to B is equal to C. Alpha, beta, gamma. Alpha, beta, gamma. Alpha, beta, gamma equal to 90. So I want primitive. Primitive means what I will show? This is what? Primitive. I means body centered. F means face centered. So these are the possibilities for cubic. P, this is what? P, this is I, and this is, who said? Brevis. Okay, for cubic 3 combinations are there. For orthorhombic, can you draw? Idea you got? Shall I draw that also one? Orthorhombic. What is orthorhombic? One, two, three. Difference is there or not? A, B, C values are of different dimension, but alpha, beta, gamma, these are equal to 90. All 4 we have to show. So these are about Brevis lattices. How many Brevis lattices? 14 Brevis lattices. Next, what? Even? Shake hand enduku? Time enda? Pocha? Vada? Okay, 2 minutes. Any problem? Two minutes. Right. Actually, simple cube. Enjoy. రే తోడు ఎప్పుడు వెళ్తారో తెలుసా? టేక్ ఇట్ ఈజీ. ఎందుకు సీరియస్? కొన్ని ఎంజాయ్ చేయాలి, ఫీలింగ్స్, ఆ సిచ్యువేషన్ ఎంజాయ్ చేయాలి, మర్చిపోవాలి. సీరియస్ వస్తే ఏమొస్తుంది? ఏమీ రాదు. నవ్వుతే మజిల్స్కి ఎక్సర్సైజ్ అవుతుంది, ఫేస్లో ఉన్న మజిల్స్కి. నవ్వడం కష్టం, సీరియస్ అవ్వడం ఇష్టం ఎవరికైనా. నవ్విస్తావా? కానీ వాళ్ళు నవ్వించిన అందరిని ఇప్పుడు అది రావాలి, గ్రేట్ అది. అర్థమైందా జోక్? ఆ జోకా? అదొక స్కిల్, అందరికీ రాదు నవ్వేయడం. మీరు ఇట్లే అంటే నా టైం ఎక్స్టెండ్ అవుతుంది. మరి నేనేం చెప్పాలో చెప్పి నేను ఇక్కడికే వెళ్తా. నేనేం చెప్పాలనుకున్నా చెప్పేసి ఇక్కడికి వెళ్ళిపోతాను. మీరు అడ్వర్టైజ్మెంట్ ఇస్తా అంటే నేను ఆగుతాను. ఫాస్టా? డిస్టర్బెన్స్ ఉంటే ఎట్లా చెప్పాలమ్మా? ఓన్లీ వన్ హ్యాస్ టు స్పీక్. మీరు మాట్లాడితే నేను వింటా, నేను మాట్లాడితే మీరు వినాలి. ఇద్దరం మాట్లాడుతుంటే బయటికి వెళ్ళిపోవాలి, అంతే కదా? ఒకరు మాట్లాడితే వేరే వాళ్ళు వినాలా లేదా? ఇప్పుడు నేను మాట్లాడితే మీరు వింటున్నారు, మీరు మాట్లాడితే నేను వింటా. వాడిని చేసేటువంటి చేయకుండా వాడికి ఇట్లా అన్నాడు, ఏం చేద్దాం? సరే సార్, డిస్టర్బ్ చేసిన. అదే మరి నువ్వు క్లాస్లో ఫోన్ నేను అన్నానా ఫోనే? వీళ్ళు సైలెన్స్ అయ్యేదాకా నేను ఇట్లా అడ్వర్టైజ్మెంట్ ఇస్తున్నా పోతా. మీరు తొందరగా పోవాలనుకుంటే కొంచెం స్పేస్ ఇవ్వండి నాకు, లేదంటే ఐ విల్ స్టాండ్, యూ సిట్. ఎందుకంటే సింపుల్ క్యూబ్, బీసీసీ, ఎఫ్సీసీ 3 క్రిస్టల్ స్ట్రక్చర్స్ గురించి రాయమనొచ్చు. వాట్ యూ హ్యావ్ టు రైట్? ఆల్రెడీ సమ్ క్వశ్చన్స్ ఐ కవర్డ్. షేప్ ఆఫ్ ద యూనిట్ సెల్ కవర్ చేశాను, నెంబర్ ఆఫ్ ఆటమ్స్ ప్రెజెంట్ ఇన్ ద యూనిట్ సెల్ కవర్ చేశాను. ఇంకొకటి అటామిక్ రేడియస్, లాటిస్ కాన్స్టెంట్, ప్యాకింగ్ ఫ్రాక్షన్, వీటి గురించి చెప్పి నేను పంపించేస్తా. 3 టైటిల్స్ లెంత్ అనకండి, సింపులే. అటామిక్ రేడియస్. వాట్ ఈజ్ అటామిక్ రేడియస్? యాక్చువల్లీ జనరల్గా అటామిక్ రేడియస్ అంటే ఏంటి? రేడియస్ ఆఫ్ ఆటమ్, డిస్టెన్స్ బిట్వీన్ సెంటర్ ఆఫ్ న్యూక్లియస్ టు అవుటర్ మోస్ట్ షెల్. ఒక ఆటమ్ ఇచ్చి అటామిక్ రేడియస్ ఫైండ్ అవుట్ చేయమనేది ఇంపాసిబుల్. సో వాట్ వి టేక్? 2 ఆటమ్స్ తీసుకుంటాం. సెంటర్ టు సెంటర్ ఈస్ డిస్టెన్స్. సెంటర్ టు సెంటర్ ఈస్ డిస్టెన్స్. This is R, this is R. So D is equal to how much? 2R. From this R is equal to how much? So average distance between 2 atoms. D by 2 ante enti? Average distance between 2 atoms is called as atomic radius. Generally atomic radius is expressed in terms of angstrom units. 1 angstrom is equal to how much? Sir, నేను అవుతా. Your friend is busy with mobile, so I'm waiting for him. Sir, please. ఇప్పుడే వాడికి చెప్పాను, వాడు మొబైల్ కాదన్నాడు, నువ్వు మొబైల్తోనే ఉన్నావు. సో అటామిక్ రేడియస్ అంటే ఏంటి? యావరేజ్ డిస్టెన్స్ బిట్వీన్ 2 ఆటమ్స్, బాండెడ్ ఆటమ్స్ అనుకోవచ్చు. ఆ డిస్టెన్స్ ఏమనాలి? నెక్స్ట్, షేప్ ఆఫ్ ద యూనిట్ సెల్ అంటే యూనో సింపుల్ క్యూబ్ యూ కెన్ డ్రా. బాడీ సెంటర్డ్ యూ డ్రాన్, ఫేస్ సెంటర్ డ్రా చేశారా లేదా? నెంబర్ ఆఫ్ ఆటమ్స్ ప్రెజెంట్ ఇన్ ద యూనిట్ సెల్ ఆల్సో చేశారు. నెక్స్ట్ లాటిస్ కాన్స్టెంట్ ఉంటుంది. సో వాట్ ఈస్ లాటిస్ కాన్స్టెంట్? ఆల్రెడీ దట్ ఆల్సో సెట్ డిస్టెన్స్ బిట్వీన్ 2 లాటిస్ పాయింట్స్. ఏ, ఇట్ ఈస్ ఇండికేటెడ్ విత్ లెటర్ స్మాల్. నెక్స్ట్ ఏం కావాలి మనకి? కోఆర్డినేషన్ నెంబర్. అనదర్ ఫ్యాక్టర్ ఈస్ కోఆర్డినేషన్ నెంబర్. వాట్ ఈస్ కోఆర్డినేషన్ నెంబర్? నెంబర్ ఆఫ్ ఈక్విడిస్టెంట్ ఆటమ్స్. 5 minutesలో పంపించేస్తా. నెంబర్ ఆఫ్ ఈక్విడిస్టెంట్ ఆటమ్స్ ఇన్ ద యూనిట్ సెల్. ఒక యూనిట్ సెల్ ఒక ఆటమ్ తీసుకొని దాని సరౌండింగ్స్ ఆటమ్స్ ఉంటాయి కదా, అందులో ఈక్వల్ డిస్టెన్స్ ఆటమ్స్ ఆఫ్ సింపుల్ క్యూబ్, బీసీసీ, ఎఫ్సీసీ సేమ్ ఉంటాయా? బికాస్ నెంబర్ ఆఫ్ ఆటమ్స్ ఇన్ సింపుల్ క్యూబ్ ఎన్ని, నెంబర్ ఆఫ్ ఆటమ్స్ ఇన్ ఎఫ్సీసీ ఎన్ని, నెంబర్ ఆఫ్ ఆటమ్స్ ఇన్ బేస్ బాడీ సెంటర్డ్ ఎన్ని? 2. సో అన్నప్పుడు నెంబర్ ఆఫ్ ఈక్విడిస్టెన్స్ ఆటమ్స్ విల్ బి సేమ్? నో. ఫర్ సింపుల్ క్యూబ్ ఇట్ ఈస్ 6. సింపుల్ క్యూబ్ హౌ మెనీ? 6. ఎట్లా? టేక్ దట్ కార్నర్. ఇది 1 ఆటమ్, సెకండ్ ఆటమ్, థర్డ్ ఆటమ్, ఫోర్త్ ఆటమ్, సేమ్ ప్లేనా? ఫిఫ్త్ ఆటమ్, సిక్స్త్ ఆటమ్. ఈక్వల్ డిస్టెన్సా డిఫరెంట్ డిస్టెన్సా? 4 ఆటమ్స్ ఇన్ దిస్ ప్లేన్, 1 above plane, 1 below plane. that is called as coordination number. What is coordination number? Number of equidistant atoms of simple cube. బాడీ సెంటర్లో ఏముంటాయి? ఇది బాడీలో మిడిల్ ఆఫ్ ద బాడీ ఒక ఆటం ఉంది, దాని ఈక్వల్ డిస్టెన్స్ ఎన్ని ఆటమ్స్ ఉన్నాయి? థింక్ అండ్ సే. ఇది ఆటమ్, ఇది యూనిట్ సెల్. ఈక్వల్ డిస్టెన్స్లో దీనికి ఎన్ని ఆటమ్స్ ఉన్నాయి? 8. 1 2 3 4 5 6 7 8. సో కోఆర్డినేషన్ నెంబర్ ఆఫ్ బాడీ సెంటర్డ్ ఆటమ్ ఎన్ని? 8. ఫేస్ సెంటర్డ్లో 12. 4 in one plane, 4 above plane, 4 below plane. 4 plus 4 plus 4 12. So that is coordination number. ఇంకొక లాస్ట్ ఫ్యాక్టర్ ఏంటి? ప్యాకింగ్ ఫ్యాక్టర్, which is equal to n into small v by capital V, where n stands for number of atoms. N stands for number of atoms, V stands for volume of atoms, and capital V stands for volume of the unit cell. సింపుల్ క్యూబ్లో n వాల్యూ 1, ఫేస్ సెంటర్లో 4, బాడీ సెంటర్లో 2. వాల్యూమ్ ఆఫ్ ఆటమ్, వాట్ ఈస్ షేప్ ఆఫ్ ఆటమ్? స్పెరికల్. వాట్ ఈస్ వాల్యూమ్ ఆఫ్ స్పియర్? 4/3 pi r cube. And what is capital V? Volume of the unit cell. What is the side of the unit cell? A. Volume means a cube. But simple cube la A is equal to 2r. Okay. Similarly, A for body center √3/4r వస్తుంది అనుకుంటా, and A is equal to 2√2r for face center. That calculation you will be seeing in the next class. Okay na? So that when you substitute, packing fraction will be same or no? It will be different. Okay. Right, thank you.